Question 11, and we're beginning to look at functions. We're given two functions. The first, f of x, is defined as x times by x minus 2. The second function, g of x, is defined as x plus 5. We are told a number of things. We're told that f of a is equal to g of a. So there's a value a which, when substituted into here and substituted into here, gives us the same answer. Our job is to find a. We're also told in the question that a is greater than 0. In other words, a is positive. And we're also asked for 3 significant figures. That will become relevant in our choice of method. So, since f of a and g of a are equal, let's substitute a into these equations and go about solving it. If a goes in here, it also goes in here, and we get a brackets a minus 2. Similarly for g of x, if x is a will go in here. Now we need to try and solve this. So first I'll expand the brackets. I'm now going to subtract a from both sides. And I'm also going to subtract 5 from both sides, leaving the right-hand side equal to 0. We've now got a quadratic that we can solve. However, if I try a number of methods, I won't get very far, but I've got a big clue from the question. It said 3 significant figures. If I'm not going to be getting a whole number solution, my usual method of paired brackets isn't going to work. I'm going to need to use the quadratic formula. There is a bit of confusion in this because we've got a number a that we're trying to find, and that doesn't refer to the same thing as the a in the quadratic formula. The a in the quadratic formula is the quadratic's coefficient. The quadratic in this case is a squared. There's one of them, and this would be referring to how many a squareds there are. To avoid confusion, this is the general form of the quadratic formula. I'm not going to use the specific letters in there. I'm just going to use it as a template. Applying it, a, the number that we're finding, would be equal to minus b. b is the linear coefficient. The linear coefficient is minus 3. So, minus b minus minus 3. Plus or minus the square root of, again, I've got b squared minus 4 times a, and that's the coefficient 1, c, and that's the constant minus 5. And that's all divided by 2a, or 2 times 1. Now, putting this into my calculator, I get 2 answers out. Taking them to 3 significant figures, I get 4.19 when I put a plus in, but when I change it up on the calculator and put a minus in, I would get minus 1.19. I don't want that. I only want the positive solution. That doesn't necessarily mean I'm going to take the positive and not the negative. It's the result which counts. So in this case, when there's a plus in this equation, I get positive 4.19. And when there's a minus here, I get minus 1.19. I'm ignoring the minus 1.19 and just taking the positive solution, as that fits what the question asked for.